Hey guys, so now that you've learned how to find a missing side or a missing angle in an oblique triangle, remember those are non-right triangles, we're going to look at how to find areas of oblique triangles as well. And depending on what information is given, sometimes it's easier to find the area of a triangle using one method versus another method. So I'm going to show you three methods. I'm going to start with one that you're already familiar with. The common formula for the area of a triangle, you might recall from geometry, is 1/2. So the area is equal to 1/2 the base times the height of the triangle. And so if we look at the first triangle, we've got the base right here, and we've got the height as well. Remember, the base has to be perpendicular to the height, and the height has to be perpendicular to the base, and it has to form a right angle. So base and height has to be perpendicular. And so we can find the area of this triangle using my common formula. So the area is equal to 1/2 the base, which is 4, times the height. So that's going to give me an area of 4 square feet. Okay, and then if we look at the second one, now just because the side is shown on the bottom doesn't necessarily mean that it's the base or that we're going to use it as the base in the formula. Remember, we need the height. So in this case, the height of 4 is perpendicular to the side BC, and I'm going to use that as the base of my triangle. So I can kind of rotate the triangle and turn it so that 7 is the base, and then the height is perpendicular to it, and that's 4. So using the same formula, the area is 1/2, base is 7, times the height, which is 4, and we have 1/2 of 4 is 2, times 7 is 14 units squared. Units are not given here, so I'm just going to put units. And then this last one, although it looks like I don't have the height, in fact I actually do, because if you recognize these three sides, 3, 4, 5 is actually a Pythagorean triple, meaning that 3 squared plus 4 squared equals c squared satisfies the Pythagorean theorem. And if it satisfies the Pythagorean theorem, it means it's 3 sides of a right triangle. So actually, this right here is a right angle, because we know that these 3 sides satisfy the Pythagorean theorem. And so if that's a right angle, then we can let either 3 or 4 be the base. We can turn the triangle and let 3 or 4 be the base. And then the other side is going to be the height. Okay, so I'm going to turn it, and I'm going to let 3 be the base and 4 be the height, as long as the base and the height is perpendicular. In this case, it doesn't matter which one is which. So we've got the area as 1/2 the base times the height, and the area is going to give me 6 square feet. So in order to use this common formula to find the area of a triangle, what we need is the base and the height. And remember, they have to be perpendicular to each other. Now let's look at the next triangle. Here in this triangle, we don't have a right triangle. We don't have a right angle, right? All we're given is that one side is 2 feet and another side is 4 feet, and we're given an angle in between. So in this case, we're missing, if I were to use 1/2 base times height, I'm missing the height. And if I let 4 be the base, the height that I'm looking for, I can draw it. This will be the altitude of this triangle, or the height. It has to be perpendicular to the base. Okay, and because it's perpendicular, it forms a right angle. And so this height is what I'm looking for. And if I have that, then I can use 1/2 base times height, right? Now, in order to find this height, we can use what we know about trig. We can use SOHCAHTOA, because this little triangle, little right triangle, is a right angle. This is a right angle, so we've got a right triangle, and so we can use SOHCAHTOA. We're looking for the height. We know that the hypotenuse of this little triangle is 2 feet, and so we're looking for the opposite side of 50, and we're given the hypotenuse. So opposite over hypotenuse, we're going to use sine. So I'm going to say that the sine of 50 degrees is equal to opposite, which is the height, over the hypotenuse, which is 2. And so the height is simply 2 times the sine of 50 degrees, and then I can put that into my calculator. And so once I have the height, then I can use my formula. Area is equal to 1/2 the base times the height. In this case, area is equal to 1/2. The base is 4 times the height, which we calculated to be 2 times the sine of 50 degrees. And then I can put all that into my calculator, and that will give me my area. Now, this formula that we just did in calculating the height and now 1/2 base times height, there is actually a formula, a trig formula, to find the area of a triangle if I'm given 2 sides and the measure of an angle in between those 2 sides. That formula is exactly what we just did. The area of a triangle can be given by 1/2 B times C times the sine of angle A, where B and C are the 2 sides that you're given, and angle A is the measure of the angle in between those 2 sides. So if I label this angle triangle ABC, then 4 is my little b, side opposite angle B, and 2 is little c, and angle A is 50, and it's the exact same thing. So area is equal to 1/2 little b, which is 4, little c, which is 2, times the sine of angle A, which is 50 degrees. And so we just did that without knowing this formula, but this is the formula, the trig formula, to find the area of a triangle if I know 2 of the sides and the measure of the angle in between those 2 sides. And so in order to use this formula, I need SAS. I need to know these information, 2 sides and the measure of an angle in between those 2 sides. And if I calculate that out, make sure your calculator is in degree mode now that we're in degrees, and rounding to the nearest 100, the area is roughly 3.06 square feet. So second formula to find the area of a triangle, if you don't have the base and height, is this trig formula, and certainly you can break it into parts if you want instead of memorizing this formula. And that's not something that you have to memorize right now because of the quarantine, but if we're in school, you would. All right, and then the very last one. This one's tricky because here we do not have, we don't have a right triangle, right? 2, 3, and 4 doesn't satisfy the Pythagorean theorem, and so it's not a right triangle. And we don't have SAS. We do have 2 sides, but we don't know an angle that is in between the 2 sides, and so we can't use the method, the formula that we just used previously. Now, certainly, if you really wanted to, we could calculate the measure of this angle by using law of cosines, right? Because we can start with the opposite side. 3 squared is going to be equal to 2 squared plus 4 squared minus 2 times 4 times the cosine of this angle. And so using the law of cosine, we would be able to find this angle. And then we can do the same thing that we did before using the trig formula. Now we have SAS, we can use that angle to solve for the area. So that's one way, but that's a lot of work. So I'm going to show you another way. I'm going to say, again, label this triangle ABC. Another way to find the area of a triangle when you're given 3 sides and it's an oblique triangle is using something called Heron's formula. And Heron's formula states that the area of a triangle can be calculated by the square root of S times the quantity S minus A, where A is the length of the side opposite angle A, times S minus B, where B is the length of the side opposite angle B, times S minus C, where C is the length of the side opposite angle C. And what is this S? S is the semi-perimeter, what we call a semi-perimeter, which is really half of the perimeter. So the semi-perimeter, you're going to calculate S by adding up all the sides, so little a plus little b plus little c, and then dividing by 2. So semi-perimeter, half of the perimeter. And so if I follow this formula to find the area of this triangle, and this is for a triangle of 3 sides, I can say that the area of this triangle, let's start by finding the semi-perimeter. S is, in this case, is going to be 2 plus 3 plus 4 divided by 2, which is going to give me 4.5. And so the area is going to be the square root of, hopefully I don't run out of space there, 4.5 times 4.5 minus little a, which is 3, doesn't matter which one you start with, times 4.5 minus little b, which is 4, times 4.5 minus little c, which is 2. And then we can calculate that out. And you can put all of this into your calculator at once, just be careful of your parentheses. And rounding this to the nearest hundred, this is going to give me about 2.90 square feet. And so here is Heron's formula for finding the area of a triangle, of an oblique triangle, if you're given the 3 sides and you don't know any of the angles. And so in order to use this formula, what we need is we need side, side, side. We need to know the length of all 3 sides. And so as you do the practice examples, make sure you look at the triangle, identify what information you're given, and see which method you're going to use that would be the easiest to calculate the area of that triangle.